One of the most common practical applications of Faraday's law is that of an electrical generator. That is, when we induce a voltage around a loop by moving a wire with respect to a magnet or changing the flux through that loop, we induce a voltage, and this is exactly what occurs in an electrical generator, whether it be one on your bicycle or one at a power plant. They're all the same principle. If you want to take a look, here's a stylized one. It's some sort of coil is set up to rotate in a magnetic field, and we use some sort of sliding contacts to maintain contact with the two ends of that coil as it rotates around. Now, if we're going to use this energy, it actually takes mechanical energy to turn that coil in a magnetic field, and that's the energy we're using as it's delivered as electrical energy later. In a simple coil, we just maintain contact with the two ends, and it'll induce an oscillating voltage as the flux changes from positive to negative, and that rate of change changes. So let's take a look. Here's a generator. It has some magnets and some rotating coils, and these coils maintain contact and are hooked up to a meter. So I'm going to go ahead and spin this, and as it turns, you'll see a voltage induced. But there's one more feature. Take a look. As I spin it around, you'll probably notice that the voltage does not go positive and negative, but stays between 0 and a value on one side. What's the reason for that? This is a special armature that every time it rotates a half a turn, it switches contacts. So in a way, it's always increasing the flux or decreasing the flux through that one half of a cycle, and then repeating that half of a cycle. We'll take a look. If we rotate the other way, then we'll be changing the flux in the opposite sense, and we'll get a DC voltage induced in that opposite sense. So because the contacts switch every half cycle, there's a gap in the armature that switches which sliding contact touches which wire. The voltage remains one sign as long as we turn it one way, so that the sense of that flux increasing is the same. Or if we turned it the other way, we'll have decreasing flux when before we had increasing flux, and so now the sign of the voltage induced will change. So this is the same principle used in most electrical generators.